whenever we are adding or subtracting fractions, we want to make sure that the denominator, which is the number at the bottom, is the same for both fractions. So in this question, we have 1 over 8, or 1/8, plus 3 over 8, or 3/8, which means that we have a shape where one of the parts is shaded. We have another shape in which 3 of the parts are shaded. So if we count the total parts that are shaded, that will be 1, 2, 3, 4. So whenever our denominator is the same, what we can do is simply add the numerators, which is the top numbers, and keep the denominator, which is the number at the bottom, the same. So 1 plus 3 is 4, and the denominator stays the same, which is 8. So as we saw in our diagram, we had 4 parts out of a total of 8 that were shaded. We can then check if our answer can be simplified, meaning if we can write our answer as a smaller number. To do this, we have to check for the highest common factor of the numerator and the denominator. So the numerator is 4, the denominator is 8, and we need to check which times table both of these numbers appear in. So we have 4, which is in the 4 times table, and 8 is also in the 4 times table. So we can divide both the numerator and the denominator by 4 in order to write this in its simplest form. So 4 divided by 4 is 1, and 8 divided by 4 is a half. If we ignore each of these lines in both the shaded and unshaded parts, and just look at the line which is separating the shaded and unshaded part, we can see that this is the same as a half. So what we have just done is we have written our answer in its simplest form, which is 1 over 2, or a half. Here we have 2 fractions which have different denominators. So here we're going to look at 2 different ways in which we can add these fractions. So the first method is where we look for the LCM of both the denominators. Our denominators here are 8 and 12, so we need to look for the LCM of 8 and 12. The LCM is the lowest common multiple. To find the LCM, we can first look at a few multiples of 8, numbers that appear in the 8 times table. And we can then look at a few multiples of 12, numbers that appear in the 12 times table. So as we can see, we have got a common multiple in both these times tables, which is 24. So what we are going to do is we're going to put both of these fractions over 24. We are then going to write both of these fractions such that we can write them equivalent to something over 24. So in order to make 8 into 24, we have multiplied 8 by 3. So we have to do the same thing to the numerator. The numerator is 3, so 3 times 3 gives us 9. In order to make 12 into 24, we have multiplied it by 2. So we have to do the same thing to our numerator, which is 5. 5 times 2 is 10. And now, because both our denominators are the same, we could just add the numerators up. So 9 plus 10 gives us 19, and our denominator remains 24. So our final answer is 19 over 24. Another method to add and subtract fractions is to use the cross multiplication trick. In this method, we still want to make the denominators of each of the fractions equal, and in order to do that, we first multiply the denominators together. So 8 times 12 gives us 96, so we could put 96 as the common denominator. To get the numerator for the first fraction, we want to multiply the 3 across with the denominator of the second, which is 12. So 12 times 3 gives us 36, so we could put 36 there. And to get the numerator of the second fraction, we want to multiply across with the denominator of the first fraction. So 5 times 8 is 40, and we can write 40 as our second numerator. We then need to add both the numerators, so 36 plus 40 gives us 76, and the denominator remains 96. Now this is not in its simplest form because both of these numbers are even numbers. So even numbers can be divided by 2, but also these can be divided by 4. We're going to use the highest common factor. So we are going to do 76 divided by 4 and 96 divided by 4. 76 divided by 4 gives us 19, and 96 divided by 4 gives us 24. And that is our final answer in its simplest form. As we can see, both these methods gave us the same answer, so we can use either of these methods to help us add and subtract fractions. The method is the same for subtracting, and I have put links with more examples of both of these methods in the description box.